Hi everyone, myself Chandrapratap Reddy from the Department of Electronics and Communication Engineering. Today we are discussing about analysis of LTI Discrete-Time Systems using convolution from the subject Digital Signal Processing. In this seminar, we have to discuss about Introduction to LTI Discrete-Time Systems and Convolution Sum Formula, Graphical Interpretation, Properties of Convolution, and Step-by-Step Computations, Casual and Stable Systems, Jet Transform Connection, FIR Digital Filters, Applications and Conclusion. Now come to Introduction to LTI Systems. An LTI system satisfies both linearity and time-invariance properties. Linearity means superposition holds, scale or sum inputs give scaled or summed outputs. Time invariance means a shift in input causes an equivalent shift in output only. Discrete time systems operates on sequences of x of n, where n belongs to z. The impulse response of h of n completely characterizes an LTI system. If h of n is known, the output of any input can be computed via convolution, where LTI systems are backbone of a digital signal. Convolution Sum Formula. The output of y of n is given by y of n is equals to summation x of k into h of n minus k for all k. Equivalently, y of n is equals to x of n into h of n, where star denotes convolution mean. Each output sample is a weighted sum of past and present input samples. The weights are determined by the impulse response h of n minus k. For finite length signals of length n1 and n2, then output length is n1 plus n2 minus 1. The convolution sum is computed for every integer n from minus infinity to plus infinity. For causal FIR systems, where FIR means frequency impulse response systems, finite response systems, the sum has finite and bounded limits. Graphical interpretation of convolution. Convolution can be visualized graphically using four operations such as represents, fold, shift, multiply and sum. Folding means reverse h of k about the vertical axis to get h of minus k. Shifting means slide h of minus k along the n-axis to form h of n minus k for each n. Multiplication means multiply overlapping samples of x of k and h of n minus k. Summation means sum of all products to obtain the single output value y of n. Repeat this shift to multiply sum steps for all values of n. Properties of convolution. Commutative means x of n convolution of h of n is equals to h of n convolution of x of n, where input and impulse response are interchangeable. Associative, x of h1 into h2 is equals to h convolution of h1 convolution into h2, where order of cascaded systems can be swapped. Distributive means h into h1 plus h2 is equals to h1 convolution x convolution h1 plus x convolution h2, where parallel systems can be combined. Identity means x of n convolution delta of n gives x of n. It gives a impulse response is identity element. Shift means if y of n is equals to h of n in convolution of x of n, then x of n minus k convolution h of n gives y of n minus k. Z domain means convolution in time. That implies multiplication in Z domain. These properties are fundamental to filter design and system analysis. Step-by-step computations. Step 1. Represent a write x of n and h of n as sequences with their ranges. Step 2. Fold. Reverse h of k gives h of minus k by reflecting about n is equals to 0. Step 3. Shift. Move h of minus k by n positions gives h of n minus k. Step 4. Multiply. Compute element-wise products h of k into h of n minus k. Step 5. Sum. Add all products to obtain output y of n for that n. Step 6. Repeat steps 3 to 5 for every integer value of n. Tabular method to all is also widely used for systematic hand computation. Casual and stable LTI systems. Causality means an LTI system is a casual if h of n is equals to 0 for all n less than 0. A casual system's outputs depends only on the present and past inputs. Stability, boundary input and boundary output. Output is bounded for every bounded input. BIBO stability condition. Summation mod of h of n less than infinity means absolutely summable impulse response. For FIR systems, finite length h of n is BIBO stability is always guaranteed. IIR means infinite impulse response systems require checking the pole locations in Z-plane for stability. Casual plus stable systems are realizable and suitable for real-time processing. Connection with Z transform. The Z transform converts discrete time sequences to the Z domain. Convolution in time gives multiplication in Z domain y of z equals to x of z into h of z. The transfer function h of z equals to y of z by x of z fully describes the LTI system, means linear time invariant system. Poles and zeros of h of z determines the frequency response and stability. Inverse z transform of h of z gives the back impulse response of h of n. Z transform simplifies convolution from summation to multiplication. This relationship is a foundation of digital filter and design analysis. FIR means finite impulse response. Digital filters via convolution. FIR, finite impulse response filters are directly implemented using convolution. The filter output y of n is equals to summation h of k into y of x of n minus k for k is equals to 0 to m, where m is a filter order. Each coefficient of x of k is a tap 8 derived from the desired frequency response. FIR filters are always stable since the impulse response is finite. They can be designed to have linear phase critical in audio or communications. Hardware implementation uses delay elements Z inverse, multipliers and adders. FIR filters are most common applications of discrete time convolution. Practical applications are digital filtering like low pass, high pass and band pass FIR filter design. Audio engineering such as convolution reverb simulates real acoustic environments. Echo cancellation. It is used in teleconferring and mobile communications. Image processing such as 2D convolution for blurring, sharpening, edge detection. Channel modeling models multipath propagation in wireless communications. Speech processing feature extraction in speech recognition systems. Control systems computing system response to arbitrary input signals. And then conclusion. Convolution is the core mathematical tool for analyzing LTI discrete time systems. The impulse response H of n fully categorizes any LTI system's behavior. Convolution sum H of n is equals to summation H of k into H of n minus k gives direct input output relationship. Give key properties: commutatively, associativity, distributivity, simplifies analysis, causal and BIBO stable systems and realizable for a real-time signal processing. Jet transform converts convolution to multiplication, enabling efficient design. Application span digital filtering, communications, image, audio and control. Thank you.